Hi everyone, we are the Railveyor group and we have been sponsored by Railveyor and mentored by Dr. Brad Ross, and our group is composed of 6 members: Selma, Jake, Jason, Abraham, Anna, and Juanita. I'm Selma Antonio and I'm gonna go over the introduction. So right now hauling in the mine industry is primarily done by haul trucks. Before talking about Railveyor, I would like to talk a little bit about some of the challenges that we face with haul trucks. One of the challenges with haul truck is the financial struggles due to rising operating costs and declining shipping rates. Another problem with haul truck is their contribution to the increase in carbon emission. And one more challenge that we face is the fact that it is also a contributor to the increase in the fatality rate in a mine. However, a haul truck does have its benefits, like flexibility. Haul trucks can have their roads and timing adjusted to individual requirements. So I talk a little bit about the challenge that we face with haul trucks. And one of the ways of overcoming those challenges is by using Railveyor. A Railveyor train is simply made of any number of individual U-shaped steel rail cars which are connected to each other with steel clevis assemblies and flexible flaps that prevent material leakage. The rail car ride on a steel wheel with heavy-duty automotive bearings. A lead car with 4 wheels instead of 2 is placed on the head of each train and is equipped with safety signals. The Railveyor system promises and delivers dramatically better results in terms of emission and profitability when compared to competing haulage solutions. It was possible to achieve these results by integrating industry-leading automation software with modern electric drive station and easily relocate light rail infrastructure like rail cars and so on. Now that I have explained what is a Railveyor and the benefits of using a Railveyor, I'm gonna let one of my group members to take over.
Hello, I'm Ana Santa Macy. For the project scope, Railveyor asked us to assess and determine how their product would fit in a surface mine operation environment. On this assessment, including 2 phases, phase 1 was implementing Railveyor haulage system in an already existing static environment. Where the roads do not change, we simply had to replace the trucks on the road with Railveyor haulage system. In the second phase was assessing how the Railveyor system would fit in a more dynamic or changing environment with the open pit. Railveyor being the main haulage source from the pit to the destination.
Hi, my name is Jake Bedlington, and I'll be talking to you about the location of our project. So our project is based at a theoretical open pit mining operation consisting of 2 distinct phases. Phase 1, shown by the green line in the image, is a simple route measuring just under 5,200 meters. This phase begins at the mine's primary crusher and ends just outside of the open pit. Phase 1 is meant to determine how effective Railveyor is at replacing traditional haul trucks over long, straight sections of road. From the crusher to the end of Phase 1, we can see grades starting close to 0% and then slowly getting steeper up to grades of around 10%. This grade is going to allow for a significant amount of energy to be produced by loaded carts, since they'll be going downhill to the crusher, further decreasing our operational cost. Moving on to Phase 2, shown by the yellow line in the image, begins at the end of Phase 1 and ends at the bottom of the pit, where the carts are going to be loaded. Phase 2 is meant to test Railveyor's capability in a more complex environment compared to Phase 1. This will require much more energy than in Phase 1 because fully loaded trains will be going up a 12% grade for the majority of the phase. In total, the distance between the crusher and the bottom of the pit is approximately 11,200 meters. The length of track will be double that at 22,400 meters. Because our system will be in a looping configuration where one track will lead loaded carts to the crusher and the other will return empty carts back to the pit.
My name is Jason Ellett. We will now be getting into the results of our project. For Phase 1, we kept all variables the same, only interchanging haul trucks and Railveyor. We determined that we would need 12 CAT 793 haul trucks. In the graph for Phase 1, we see that Railveyor has a higher capital cost. However, due to its extremely low operational cost, it is more economically viable in the first year of operation. This is in part due to the fact that Railveyor produced more energy than it used. In a scenario of replacing already existing haul trucks, it becomes more economically viable in just over 2 years. For phase 2, for running the entire mine, it was determined that 30 haul trucks were needed for this mine. For Railveyor, it was determined that we would need 9 supporting haul trucks to transport the material from the working face to the actual carts. In this scenario, we find that the Railveyor option has half of the operational costs and less emissions than the 30 haul trucks, the traditional option. We find that the Railveyor option becomes more economically viable in 2.5 years. Over the total life of the mine of 20 years, we find that the Railveyor option will run just over $1 billion, and traditional haul trucks will be closer to $2 billion.
Hi, my name is Juanita Parkerson, and now I would like to talk about capital cost. To install Railveyor, we'll need to rent 7 different types of equipment, plus fuel brings us to a total of $493,000. We'll need to purchase 2 types of equipment, which is 1 hopper and 3 apron feeders, which is a total of $3.1 million. To install Railveyor, we'll need electricians, operators, and laborers. For both phase 1 and 2, it brings us to a total of $520,000, which brings us to our grand total for installation being $4.1 million.
My name is Abraham Estopayan. As per our results, Railveyor has a high startup capital cost, but it more than makes up for it in having a low operating cost, running on electricity rather than diesel. In our phase 2 design, the operating cost of Railveyor is nearly half the operating cost of running haul trucks. Railveyor is more economically friendly because it reduces diesel usage as less haul trucks are used in the mining operation. In one of our designs, nearly 8.4 million gallons of diesel were saved annually because we replaced a portion of haul trucks with Railveyor. We also save on water usage because we do not utilize water trucks as much to suppress dust from the haul trucks, as Railveyor runs on a set of tracks instead of the haul road itself. In 2 years, we start to save money operating Railveyor compared to a full fleet of haul trucks. The more complex the hauling design with Railveyor, the higher capital cost will be. But with its low operating cost, it will save money compared to operating haul trucks in just about any scenario. Our designs were for a static haul road with Railveyor loading from a central point, going to a crusher, and loop back around. This yielded promising results. As Railveyor is explored more, this technology could be a viable alternative hauling system in the mining industry. We would like to thank our sponsors, Railveyor, and the mining department professors for all the support in this project. We have been Team 23103.